Well, finally, we have to find the intercepts of f of x equals x to the fourth plus 7x squared minus 8. Well, to start off with, let's just find the y-intercept. So to do that, we'll let x equal 0. So we're going to evaluate f of 0. And f of 0 equals, we're replacing x with 0 here and here. We'll wind up with just minus 8. So the y-intercept is at, and I'll just do it this way, y dash I is at 0, negative 8. Next step, we have to find the x-intercepts. So to do that, we'll set f of x equal to 0 and solve. Well, that means that x to the fourth plus 7x squared minus 8 must equal 0. Well, we have to factor that in order to find the zeros. So let's break this middle term up into a couple of terms, factors of 8 that have a difference of 7. So we've got x to the fourth and two factors of 8 that have a difference of 7 are 8. So we have an 8x squared minus an x squared minus 1x squared is 7x squared, and we still have this negative 8 hanging out here. And now let's see, we can factor an x squared out of each of these terms, x squared times x squared plus 8. And we can factor a negative out of each of these terms, and we get x squared plus 8 equals 0. Now we can factor an x squared plus 8 out of each term, and we're left with the unaccounted term or factor in this term is x squared, and there's that minus, and the unaccounted factor in this term is 1, because what times x squared plus 8 equals x squared plus 8? Well, that's 1, isn't it? Now, this x squared plus 8 does not factor. On the other hand, this is a difference of two perfect squares, and it does factor. So it factors into x minus 1 times x plus 1, and that equals 0. So now, what values of x will take this product to 0? Well, nothing. There's no real number that'll take this factor to 0, but if x is negative 1, that factor will become 0, and the product will become 0. If x is 1, this factor will become 0, and the product will be 0. So consequently, our x-intercepts are at negative 1, 0, and 1, 0. And just to consolidate, our y-intercept occurs at 0, negative 8. And we're done.